Okay. Hi, good morning, good afternoon, everyone, depending on the time zone you're in. Thanks for joining us today as we discuss modern observability solutions, and we appreciate your time to be here with us. I'm Manish Arora, part of worldwide Amazon OpenSearch specialist team at AWS. I spent over 10 years with analytics in the analytics field and about 20 years in the IT industry. With me, I have my colleague Prashant today, who has worked with OpenSearch and working in OpenSearch and worked with Elasticsearch for several years. Together, we'll spend an hour today with you to share all about observability as part of Amazon OpenSearch service stack and how it could help you to find and fix the problems faster and better. Before we get started, just a couple of housekeeping announcements. Please keep yourself in the mute mode if you're not, and mention your first name and the last name so that we could recognize who's the person talking to. And the third thing is there will be survey which will be sent via email, but there's a chat. We have experts on the chat who can actually answer your questions in real time. So with that, let me just get started, stop my video, and get this going. So this is our agenda for today. With the growth of distributed systems running in the cloud, the need for a comprehensive observability solution, which can enable you to quickly identify performance issues faster across microservices, has become critically important. And our session today from this outline will actually include a quick introduction of best-in-class open source OpenSearch solution. We'll define observability, the difference between observability and monitoring, because we hear that a lot between monitoring and observability. We'll focus on the OpenTelemetry standard, why it is becoming the de facto standard for implementing observability. Then we look at the OpenSearch observability stack. And then we will look at the key components of the solution and how those can actually help you build architecture and help build architecture for the users. So overall, the session is divided into three parts. We'll spend first 10 minutes or so introducing observability and its growing need for the business. We'll dive deeper into the architecture and introduce key components for the next 30 minutes or so. And in the third part, we'll have an actual demo followed by Q&A. So in the end, we will share a few useful resources with you to help you get started with free trial, workshop, etc. So just to repeat, before I move to the next slide, do not hold back your questions. Please keep asking us, and we have our experts to answer you that. A quick introduction to OpenSearch. OpenSearch is an open source solution based on Apache Lucene engine. The value of OpenSearch is to help you find the right kind of information, to give you insights into a large corpus of data, whether it is search use case or the log data. The biggest use cases for OpenSearch are search, observability, and security use cases. We have a vibrant community of developers, corporations, and partners who are contributing to making OpenSearch feature-rich every day. OpenSearch has released 4 versions in a little more than a year, starting with OpenSearch 1.0, followed by 1.1, 1.2, and recently released version 2.0 with some very innovative features, including new Lucene engine and several observability features. There are millions of downloads for OpenSearch currently, which is a good news for the open source community. OpenSearch is on the GitHub with the publicly available roadmap to provide you with information on OpenSearch direction, continued innovation, and timelines for the upcoming features. So you can essentially go to opensearch.org and find out what's going on and what's the direction. It's a powerful engine, OpenSearch, that makes these different use cases possible. Well, the first case is self-evident, that is search. It's a search engine that provides a distributed inverted index for performing full text search with support for natural language, Boolean queries, faceting, broad language support, and relevancy tuning capabilities. It is also optimized to support indexing of high volumes of data, making it available to search in real time for the streaming data. Here, the data is sharded and distributed, enabling scaling for high volume indexing and high performance query. Combining a search engine with high performance streaming indexing can be a powerful combination for analyzing machine generated data and provide rich analytical and data visualization tools, enabling your users to get real-time insights into applications, infrastructure, security, and more. Now that was about OpenSearch. What is Amazon OpenSearch service? Amazon OpenSearch service is a fully managed service for OpenSearch that helps customers address their needs cost effectively, securely, and at scale. That's what the Amazon OpenSearch service does. It was formed about a year ago. It was previously called Amazon Elasticsearch Service. We renamed it primarily to do open source OpenSearch distribution. We still support Elasticsearch distribution from 1.x all the way up to version 7.10. And from there onwards, we offer OpenSearch. We currently have OpenSearch version 1.2 as the latest on the service. While I shared in the earlier slide, OpenSearch is on 2.0, so that'll come on the service soon. So what is observability? We are all here to discuss that today, and that is our today's topic. There are multiple definitions, but observability as part of the OpenSearch stack is the definition is, it's actually a term which got popularized in the last few years or so with the growth of distributed systems running in the cloud. That generated the need for a comprehensive observability solution. Observability solution has become important to enable quick identification of performance microservices and to find out what's going on when we have all these different applications in the microservices architecture. It provides, observability provided by a service mesh makes it much easier to see what's happening when your services interact with each other, making it easier to build a more efficient, resilient, and secure microservice architecture. It allows teams to actively debug their system. It is based on exploring properties and patterns not defined in advance. It actually solves the problem of, in a way, if you look at it, unknown unknowns by allowing you to automatically and continuously grasp new types of problems as they emerge. And it includes a set of tools and processes that DevOps teams can use to understand the root cause of any issue they are facing. And these issues could be availability, or it could be capacity planning, or cost optimization initiative. These observability tools help you to identify the true cost, which is the purpose of this. And I'm sure you're hearing multiple definitions, but I thought some of these would be relevant here. Finding logs is tough, as we all know. Lots of searching and filtering are required. This is a snapshot of Apache Weblog. It contains tons of information, but the signal is buried in the noise. And the problem is, how do you find the root cause by looking at the complete state of the system? I mean, machines can correlate the data, but can't really find the root cause or fix it because it is subjective based on interpretation, point of view, etc. And the cost of downtime and fixing the problem is huge. As we will see in the next slide, interruptions consume a lot of money. And there are some numbers by external agencies here which highlight the importance of time and costs associated with the downtime. And the costs here look enormous. In microservices architecture, time associated for finding an issue is of high importance and the risk is greater. So users need to find an observability solution to mitigate this risk. And that is where we come in, and that's what we are trying to share with you today. Now, let's look at observability, or before we actually look at the operational mechanics, let's also look at a little bit on the monitoring piece. So operators have been monitoring system availability and performance for years by watching gauges, charts of metrics, and looking at triggered alerts over time. Monitoring is all about looking at what you know is important or could go wrong, something that you can anticipate. Observability allows you to actively disseminate information from the entire system, including the unexpected. So it is the ability of a system to be observed by gathering telemetry to allow our builders and operators to detect, investigate, and remediate issues faster. So if you look at the three pillars here, detection is the known availability and performance of alarms that engineers set up to proactively or reactively notify them of problems. The investigation is what typically takes a majority of the time to find isolated or systematic issues across all your data sources. Remediation is how we mitigate and resolve impacts and downtime, as well as automate, wherever possible, by having the operational procedure for the resolution. The three typical signals that make up the foundation of observability come from metrics, logs, and traces. At a high level, metrics is measurements over time, logs is unstructured data, and traces is cascading effect or impact upstream or downstream. That lets you understand dependencies in a transactional flow at a high level. So that's how the foundation is, and we are going to dive deeper into this in the session today. Before we move forward, I think we have time for a poll question. Let's see if we have a poll question coming up. Excellent. So this is just to check with your interest, which is like, what's your primary interest today? Whether you're new to it, currently supporting, or you're using a proprietary solution and you want to see more, or you're like, it doesn't really apply to me. I'm here just to learn what happens in observability. So whatever is your thing, if you can let us know, we'll give it a minute. We are already 20 seconds over, so yeah, another maybe 30 seconds or so. Yeah, keep sharing with us, that'll help. It's also a good break from just hearing us. Another 10 seconds to go before we announce the results. Yep, so we have 52% who are new to observability, and there are about 30% who are currently supporting log analytics but want to explore, which is a wonderful thing because that's exactly where it is going. And there are a lot of discussions about, is observability part of log analytics or log analytics part of observability? So absolutely at the right place. I'm using a proprietary solution and I want to see what happens. Yes, absolutely. Open source is the new wave, and let's be a part of it. But thank you so much. And we have 7% who are here to learn. But thank you so much. Thank you so much for joining us. Hope this session will be useful for you. Now, I will stop sharing this. Do we have another one coming before moving forward? Yeah, so we have just one more. So the question is, the main end user of observability tools on my team are SREs, cloud operation engineers, or we are individual developers, cybersecurity engineers. Does not apply. Okay, 10 seconds more. You're almost there. This is excellent. So we have 59% SREs and cloud operation engineers. Welcome. Thank you so much for being here. Hopefully you'll find this useful, and at the end of the presentation, we'll have more questions from you, and maybe we'll have some good conversations and discussions We have 16% individual developers here. Welcome. Thank you so much. Please contribute to open source. You're most welcome to do that. Cybersecurity engineers, 6%, and there are 20% people who are new. So thank you so much. I'll stop sharing that. With that, I will, so I'm, okay. So 59%, 16%, 6%, and 20%. That's all from my side. I'll close this. So with that, we'll now dive deeper into pillars of observability, which is where we were, which is architecture patterns, popular use cases, and complete flow with observability tools from OpenSearch. And Prashant will help us to take us through that journey today, followed by a demo. Prashant, over to you. Can you take over the screen?
Thanks, Manish. So can you see my screen? I have started sharing.
I can.
Yes.
Thanks.
Okay.
Thanks for taking me over. Thanks a lot.
Yeah, no worries. So thanks, Manish, for providing the overview. And I really like the questions and the answer we got and the kind of a diverse people what we have in the call or in this session. Like we are a mix of developers, engineers, and the SRE. So basically now I will now go a bit deeper and talk about in details about these pillars. So when we talk about the pillars of observability, so first we have the logs, which is nothing but an immutable events that occurs over time to help understand unpredictable behavior. The logs can be of plain text or it could be in the structure format. Next, we have the metrics. So metrics are nothing but numeric representation of data, which is measured over an interval of time. It helps you to identify the trends, or maybe it used to understand and predict the behavior of the system. Then next we have the traces, which represents the entire journey of a request or an action which gets moved through all the nodes of your distributed system. So for example, if you're running microservice-based architecture, so how exactly your request flows through one application to other application or one microservice to other microservice. Next, we have the telemetry. So telemetry is nothing but an agent which could be running on the source system and then sends those data back to the destination or target. So you could have a human user, maybe for an example, who could restart a service based on the information they are gathering. Or in other way, you could have an application or a software, which could be a cluster or an autoscaler, which could add worker nodes based on the system utilization or the resources what you are consuming. So how exactly the proper tooling can influence both operation and business outcome? So if you have your team or the operations team, which have the visibility to all of your logs, metrics, and traces, then it can help you to address your application and infrastructure related issue in a timely fashion. And this will not only help you to develop more, it will not only help your development team to design the high resilient applications, but it will also influence the overall customer experience, and which in turn will drive the revenue and has the potential to drive new lines of business as well. So let's talk about some of the emerging use case with the observability. So first one, we have the microservice and container base. So there are dependencies on other teams and services where they need to often connect and collaborate to identify an issue. In many cases, this coordination slows down the process and basically create a friction between the problem finding phase versus the problem solving phase. So typically implementation or application logs and metrics so that you might want to know how many 400 errors are occurring in a time duration, or if you want to create trees between different microservices and measure the overall effectiveness of all the components. That can help your business to find the root cause of the issue in a more quicker and in a more quicker way. Then next we have a digital experience monitoring. So it is more focused on the interaction of humans and external interfaces, where tooling is critical to understand your business. And it makes sure that services like media and entertainment is actually working. And as in last 2 years, we all have to adjust working from home during these COVID times. And we have struggled a lot in this time. So how many of us experience the latency and poor conference quality when we are connecting with the team? Or how many of us struggle with the e-commerce website where we are putting up some order or where your order is getting delayed, maybe during the holiday season, like during the Thanksgiving or during the Christmas Eve. So that way it helps you to get the better digital experience So it overall like networking or credit card transaction processing, then user abandonment rates at the checkout, all comprises the overall experience for your customer, which at the end drives a successful business. Then talking about the DevOps or the AppOps world, most of the deployment happen using CI/CD pipeline, and it may involve ECS or EKS. In that case, you do not only have to monitor the servers, containers, and applications, but you also need to track the state of orchestrator like an API server or a key value store or maybe a scheduler. Last but not the least, if I talk about the data lakes, so observability into the resources are really required to run your ETL jobs. Maybe you want to generate data or some sort of reports for your customers. So this means you need to leverage tooling such as maybe logs from Hadoop or Spark jobs, or if you're using the Yarn, which is nothing but yet another resource negotiator for resource allocation and tuning, then it might take time for your multiple ETL jobs to generate the final report. So most of these use cases generally lands up with the microservice and DevOps world, but digital experience and data lake is also a critical piece in today's world and might need an observability lens to debug and troubleshoot the application. So talking about tooling and instrumentation, so do we really have a single tool which rules them all? So in my opinion, I would say this space is still being defined. And it's clear that open source project and a broad range of other vendor products are emerging into this space and into the new places as well. So one thing is really clear nowadays that standards and approaches are becoming the norm for the observability and which challenges the one tool to rule them all kind of concept. And in this way, OpenSearch project is really putting a lot of efforts to create centralized interface where user or operator can view all of the logs, metrics, and traces in one place. So in my coming discussions or in the conversation, I will be talking about how OpenSearch service can be used to view logs and traces in one single interface. Then we have the metrics, which is still in progress and it will be getting launched soon. So let's take a quick detour and see how exactly data flow looks like with trace analytics and observability into the Amazon OpenSearch service. If you look at this particular data flow diagram, so number one, we have set of producers on your top, on your left side, which is nothing but it could be application instances or maybe IoT devices or the AWS services. In some way, we have a set of services that are generating the log data or anything which is generating the data. Then on the middle, we have a collection layer that is going to bring all of that data forward. Then typically it could be an application you will have on your application server. Then there could be some collector that is forwarding the data. We have a couple of examples from the AWS service side, like it could be either Amazon Kinesis agent or the CloudWatch agent, which can sit on your application server. Then we also have open source lightweight shippers such as Beats, FluentD, and FluentBit. So specifically around container, these are the common choices to collect the logs data. Then we need some sort of aggregation layer. So you can actually send the data directly from the collector to the open source service. However, in order to avoid the overloading of your open source service with concurrency, you really need a layer. And that layer is going to bring all that data together and reduce the number of concurrent connector you have by building bigger batches out of these data sets. So we have some examples here where you can use the Kinesis data firehose, which can deliver directly to the open source service. Then you have managed streaming for Kafka, or you can use Amazon S3. And on the open source side, you can use the Logstash, which can collect the data from the collectors and send it to the open source service. Then aggregator layer is going to deliver all the log data to the open source service. Then you can use the OpenSearch dashboard to visualize those data sets or create the dashboard. So now we talked about the in general flow of your log data. But now when I mix up it with the observability, so you can use the OpenTelemetry at the producer layer, where you can use most popular open source formats, including Eager or Zipkin, which can then send the data to the OpenTelemetry collector at the collector layer, and then use OpenSearch data prepper, which can collect the data from the collector and send it to the open source service. So we talked about a little bit, few components about the observability at the bottom, like how and what you can use as producers, collectors, and aggregators. So let's get into details of what OpenTelemetry and data prepper is, which will help you to kind of create the observability pipeline. So at the foundation level, you have OpenTelemetry, which is a CNCF project. It is 100% free and open source. It gives you a collection of tools, APIs, and whatnot. And these could be used to instrument, collect, and export telemetry data such as metrics, logs, and traces, which can help you to analyze your software's performance and behavior. It basically supports instrumenting libraries such as Eager or Zipkin for collecting those data. Then we have AWS distro for all open telemetry, which is again secure, production ready, and open source distribution, which is backed and supported by AWS. And it provides you a single click deployment from Amazon ECS or maybe from the AWS Lambda console. So this gives you an overall picture of what and how you can use the open telemetry. Next, we will talk about the FluentBit. So on the collector side, there is FluentBit, which is a lightweight open source shipper as part of the CNCF project again. And it is super fast, scalable, and has metric processors and forwarders. FluentBit is built up on the plugin-based ecosystem, which can collect data, apply some filters to some sort of ETL, or maybe send the output to next layer of ecosystem. This FluentBit is vendor agnostic and built from the architecture of FluentD. And one of the good thing is it is extensible and has the tight integration with other AWS services or other tools such as Prometheus, CloudWatch, and whatnot. Now let's jump into the aggregator layer. So at the aggregator side, we have data prepper, which is nothing but an open source collector for processing observability data and collect data from various sources. Once data is collected, it can be used to filter, transform, and enrich data before it is sent to the target, where target is OpenSearch, and it can be used to, and then you can use the dashboard to visualize those data. As of now, Data Prepper supports the traces and logs and do have plan to integrate with Matrix in the near future. Then it also has the integration with the OpenTelemetry collector for traces and then FluentBit for the logs. So while I'm talking about all these components, what can be involved in your log analytics or the observability data flow pipeline, feel free to drop your questions in chat where we have a team of experts who can answer some of those, and then some of them can be taken as live Q&A as well at the end. So let's talk about some of the observability feature which we have with the Amazon Open Source Service. So first we have trace analytics. So trace is a collection of operations that represents a unique transactions handled by an application which constituents services. Then span represents a single operation within a trace. So for example, you have, let's say you are building a food ordering app, then trace would be an end-to-end flow where a single operation such as user clicking a button or can trigger an extended series of events. The front end then might call back and it can call to another service which can query a database, process the data, and sends it to the original service, which finally sends a confirmation to the front end. So this is how an end-to-end order works for any ordering app. So I'm just taking an example of food ordering app, which I will continue to refer in my demo and in the following slide. So trace analytics helps you to visualize the flow of every event and helps you to identify the problem. Then talking about the components, so trace span detail is a single response which gives information such as latency or maybe errors for each span, like how many 400 errors you are getting, what is the application which is taking most of the time. It can be helpful to diagnose the root cause for an error or maybe the performance issue. Then we have the service map, which aggregate all these traces and gives an end-to-end view of application environment. It could be helpful to isolate service hotspots based on the latency or the error what you're getting from the trace data. Then next we have the trace groups, which can be used to aggregate similar traces in a group and then monitor the performance and error reads for those trace groups. Next one is event analytics. So that comes with Open Source Service 1.3 onwards. With event analytics, you can use the PPL query. So PPL is pipe processing language, which can be used to build and view different visualization of your data, or you can use it to make correlation between your logs and traces. So here you can use the PPL to interactively explore the data and create the visualization of those data sets by using a set of commands which are delimited by pipe. Then you can also use stats to create different metrics and plot the visualization. Then you can use the parse command to parse a particular field using regex or maybe further pipe into other operation or commands. Once you navigate to the event analytics, what if you prefer watching all the events happening live? So you can configure an interval so that event analytics automatically refreshes the content, just like you do tail-f in Unix or Linux. So you can tail the log with a defined interval or check the surrounding logs, which occurred few events before or after the actual. Then next feature we have is the application analytics. This is also helpful to correlate logs, metrics, and traces. And also, while Manish was talking, I saw a couple of questions where people were asking, can we correlate all the log, metrics, and traces from a single interface? So yes, you can use the application analytics to create kind of a consolidated view of all of your logs, traces, and metrics. And this feature is supported starting from version 1.3. So using the, as I mentioned, using the app analytics, you can build multiple application views by selecting different log sources, trace groups, or service, which can help you to monitor the application availability and helps you to drill down and check detailed view for logs and traces in a single view. Okay, so last one is the operational analytics and the notebook feature, where OpenSearch has support for these. So metrics extraction, alerting, and anomaly detection is coming in the roadmap. But in my demo, I will talk a little bit about the operational analytics and the notebook feature, what we have. So this is just an visual illustration how the custom operation panel looks like, which is nothing but you can use the pipe processing language to create those visualizations, and it can help you to view different charts and graphs for different metrics in a centralized place. This is about the notebook. As I mentioned, it is used to tell you a story with your data. So it's nothing but a document made up of multiple cells, paragraphs of text, or maybe queries and visualization. You can share those notebook either as a URL or a link for the OpenSearch dashboard. You can also download those as PDF or PNG format and then share to your customer or share to your internal teams and users. A typical example for notebook is to design and create an operational runbook, or maybe creating an infrastructure report or creating a root cause analysis report. So we really talked a little bit about what is observability and its use cases, but do we know what is an ultimate goal for running an observability? So here, goal is to provide a better customer experience for your product. You may want to ensure that your customer believes in stability of the application and service what you provide. To put it bluntly, observability helps you get better operationally and enables your business for the overall success. If you like the metaphor, you can think of observability as using the data from plane's exhaust system and dashboard to determine what's really happening inside the plane. Whether your engine is running too hot, is your plane burning too much fuel, or is your plane having issue with the wings. So if you can answer all of these questions by simply analyzing the data you receive from plane's control system, you can literally view the surface of the plane even without tearing apart various parts of the planes, which would be too complex and time consuming. And that's where you achieve the observability. So now we know what is observability and how it works. Let's get into a quick demo and see it in action. Before getting into a demo, let me talk about the demo architecture. Anyway, we have a workshop for the observability, which I will share at the end, which you can refer to create your sample application and send those data to the OpenSearch. So in this workshop, as I already gave an example for a food ordering app. So let's consider that app has multiple microservices to complete a transaction, which could include a service for placing an order, checking the stocks, running authentication, or maybe connecting to the database and payment gateway. So here I capture all the logs from those services using FluentBit, which sends the logs to the OpenSearch. Then I have AWS distro for Open Telemetry, which captures the telemetry data and send it to the data prepper, which sends it forward to the OpenSearch service. So now let's move to the action and see how exactly observability works. So let me share. Okay. So in this demo, you can go to the OpenSearch dashboard. I'm going to log into my OpenSearch dashboard here. Once I log into the dashboard, you can click on hamburger sign on the top left and go to the tab what we have for the observability. Then in observability, we have multiple features. So let's go to trace analytics first. And here you can see there are no traces for last 15 minutes of the data, but I do have some historical data which is being collected for this demo. So if I just change from last 15 minutes to maybe today, I see a couple of data over here. But what if you want to see all those data into the real time? So let me make it to last 15 minutes. Okay, so as of now, I don't have data, but as I mentioned, I'm running a workshop. So I have simulated many operations. So this is kind of my sample app from where I can send some of those actions, which can actually trigger some call for my API or the microservices. So if you can see, I have simulated many operations such as payments, order, checkout, which may call one or many microservices. So let me click on a couple of operations over here, like I want to do checkout or cancel an order, create an order, want to check the status, then want to finally make the payment. I'm just clicking some random here so that it generates some data. Now, if I go to the dashboard and refresh my last 15 minutes, you can see whatever interaction I was doing on the application. So these various trace groups such as client pay order, create order has been generated. It also shows what is the latency for all these different trace groups. And if there are any failures, you can see the error rates over here, like 0% or my which particular application is running with 100% of the failure. So this way you can find which operation is having error as well as taking most of the time in the overall processing. So now if I want to drill down and want to check in more detail, so my checkout application, a client checkout application has 100% of the failure. Let's get into checkout and see what is happening with this service. So you can click on this particular application or the trace group, which will be adding this as a filter. And then at the bottom, we have the service map for this trace group. And that service map tells like what all services are involved for this particular application. So like I have payments, front end, and so many other services, which actually it's talking for completing the transaction. One can now go to see all the traces for this particular transaction, which is erroring out, or maybe just click on the traces at the left. But on this page itself, you have the trace error rates over time, where you can see how many errors you are getting for a particular service over a period of time, then how many number of traces you are generating. So that way you can check the throughput. So now let's go to the traces, and you can see I already have the client checkout as a filter over here. Now, when I go to the traces, that client checkout filter is already applied, and you can get any specific trace ID, which will expand more detail for a particular traces. So for example, I'm fetching one ID, which is having latency of 69.32 millisecond, which is kind of the highest latency on all of these three traces. Then clicking on it, it expands more details for this particular trace ID. It lists out the service map, like what all services are involved for this particular trace or this particular event. Then what all spans are involved and which particular spans are erroring out and how much time it's taking for a particular span. Then if you go at the bottom, it also lists down and gives you the complete payload for this particular trace, which gives you all the data which it has collected for this particular trace. And then at the bottom, you have the service map where you can see the latency in a graphical format. So once you mouse over, it will give you the throughput, error rate, and the latency. And if you just want to see the graph for the error rate or the throughput, you can simply navigate through these buttons. So from traces, I see there are some errors on the payments or the checkout page, which we saw from here. Now, if you want to check the logs of this particular trace group, so we can go to the event analytics. So that's a one-way segue how you can use the event analytics. But before going to the event analytics, let me talk a little bit about the service tab. So I already have a filter for the client checkout. Now, if you go to the service tab, it also lists down what all are connected service for this particular service. So like whenever payment service is getting called, it is also related to the analytics service and the front-end client. And there are 3 traces for this particular combination. So that way you can also find the connected service when you are actually debugging your application. So now let me go to the event analytics. Okay. So from traces, now we saw that there are error on the payments. Now, if you want to check the logs of this particular trace group in the event analytics, so event analytics helps you to monitor and analyze the data basically using through the PPL queries. So I have saved a couple of queries, one for the create order over here and one for the checkout service. So when you basically create any of those event analytics job, in that scenario, you can find the maybe maximum and average duration for a specific service. So let me go into one of the service for the checkout. If I go to the checkout service, then I'm using the PPL query where my source index is hotel V1 EPM span and trace group is client checkout. So that's what we are going to drill down and see what exactly is happening with my checkout application. Then I'm doing some sort of stats to aggregate the data at the service level and finding the maximum and average duration for the service. So on this table, you can see the breakdown of all these duration at the service level. Now, whatever stats you generated for events tab, you can also navigate to the visualization tab over here. And it helps you to see those data in a really nice bar graph where it gives you the breakdown of duration by service and also helps you to find a service taking most of the time. So this way you can see your front-end client is taking roughly around 155 milliseconds for as a max duration, whereas the average duration for the front-end client is 48 milliseconds. That way you can compare max and average. Then you can compare across service as well, like front-end client is taking 155 milliseconds versus the payment service, which takes roughly around 76 milliseconds. So this is the way how you can view the events and view the visualization of those data. Now there is an option to open a new tab. So as of now in this query, I'm doing some sort of aggregation at the service level. But what if you want to see the actual log for this particular data? So open a new tab, just write the query, and here I'm just selecting my source index and then getting a filter for the client checkout. Then once you refresh the data, so you can see here that whatever logs you have for this particular application, that way you can see the logs which is happening in the near real time. And that way you can view your traces and the logs in a single page of the event analytics. So then otherwise, we also have one feature of the live tail, which I mentioned. It could be useful when you want to see these events occurring in a kind of a timeline window as your traffic flows through. So live tail lets you stream your logs live to the OpenSearch observability event analytics based on the provided PPL query. So whatever filter and query what you are providing into the PPL, it will honor that and it will give you the data. So as soon as you get any new events, it will be coming over here in the live tail. So basically the use case of the live tail is it improves your debugging experience and lets you monitor your logs in near real time without having to manually refresh the data. Then this feature is really simple, similar to the CLI tail-f command, which I already mentioned, which you generally use in the Linux or Unix world. And it retrieves the most recent live logs by eliminating a large portion of the live logs. After you see those live data, then you can open any of these events. So if you click on this greater than sign over here, it will expand the events. And then there is a button to see the surrounding events. So surrounding events can be used to view all events surrounding to the event you have selected. So if I find out like this particular event is giving me an error and I want to see the surrounding event for that event, I click on the surrounding event and it gives me a few events before and after the actual error. So the one thing to note here is log surround does not have filter what we have for the PPL. So it actually gives the few events before and after the actual error, irrespective of the filter you are adding. And another good thing for this window is you can see, you can basically see the traces and you can go directly to the traces as well. Now, if you figure out that you have this particular event which is having some issue, then you have table, JSON, and traces tab over here. Then you can click on the traces, which again gives you all the time spent for this particular trace across different services. So now you can see the correlation between the logs and traces. You figure out one log, and now clicking on the traces, it gives you kind of a 360-degree view of that particular log and see what all applications are involved, what are the spans and traces groups for this particular trace ID. So now I can use, so basically in the traces, there is an icon which you can click, which can navigate you to the detailed view of this particular traces. And then from here, you can navigate to trace analytics page for this particular trace ID and view all of the service maps and spans and payload and what. Then another good thing is now what I'm going to do is I'm going to take this particular trace ID. You can copy this trace ID, then go to the discover. Then in the discover, you have the log data and just search for the trace ID. So this way you can see what exactly is the error happening for this particular trace ID on your app data. So I have the error like checkout operation field service unavailable 503. So that means I'm getting 503 error for this particular service. So this way you can navigate and find out the application or the service which is causing the problem. And then you can go and basically look onto that particular microservice to fix the issue. So this is how distributed tracing works and helps you identifying the problem or kind of basically tries the issue what you are having. So we talked about the trace analytics and the event analytics. If I go back to my observability page, we also discussed about the application analytics. So for app analytics, the usefulness or the importance of the app analytics is if you want to check logs and traces across different applications. For example, as I mentioned, I have a food ordering app that could be facing to my customer. But now I might have another app that is order management for my employee, or maybe an app for delivery person who can monitor the pickup and deliveries for their order. So I can create multiple application in app analytics. So I have two applications over here. One is for the payment and one is for the delivery status. So payment talks about the customer end, like who is actually placing an order. Then delivery status talks about the delivery app or a kind of a sub app, you can say, which only talks about the order status and the delivery status. So then you can use the app analytics to create custom application to view all the availability status of your application, and where you can define the availability on the basis of the errors. Like, for example, if you are getting more than 10 errors in last 15 minutes for 400, in that way you can set your availability to be maybe like yellow or red. So that way you can define the availability within your app analytics. So this also helps you to quickly move between the log, traces, and metrics. So let me go into one of the application. If I go to the payment application, here you can see all the data what you have for the trace group is related to the payment. So typically whenever payment happens, so a customer might want to create an order, then he will add that into the cart, then he will do the checkout, then he will pay the order, and then customer will check the delivery status of the order. So that's how the payment will work. Then you can see all those applications in the trace group over here. You can see the maps, then the same trace analytics view, what you were seeing on the trace analytics page. Then you have the service view where you can see all the connected service and the correlated service. Then it gives you the map across these services. When you go next, you can see the trace detail for this particular application. So that way you can find out all the traces, all the traces with respect to all the trace group along with their latency and what is having an error. Then you can see the actual logs over here for this particular application. Then you can use the panel to create some sort of visualization if you want to create some, say, some bar graph or the pie chart, etc. Then at the end, it gives you the configuration, like what is the log source for this particular application, then what all services are involved. So I have added payment and order for this particular application. So this way, you see, like trace analytics helps you to find the individual traces. Then event analytics helps you to find the logs for those traces. Then application analytics really correlate all these logs and trace data where you can see the 360-degree view of all of your applications. So as I mentioned, as of now, it supports the logs and traces, but we do have metrics in the roadmap and it will be coming soon. So once we have the support for the metrics, then you can really use the application analytics to view everything happening inside your application, be it the metrics, logs, or traces. Then we touched a little bit about the operational panel. So operational panels is nothing but you can create multiple visualizations and see the side-by-side comparison of two different visualizations. For example, I have the checkout versus the order. So you can see which particular service is taking most of the time in checkout versus which particular service is taking most of the time in the create order. So that way you can add as many visualization as you want in the operational panels. Then notebook can be help you to interactively and collaborate, develop the reports, which could be useful for doing the root cause analysis or maybe creating a postmortem report or creating an infrastructure report. So I think this concludes my demo. So as we saw how the things work with respect to the observability, so we have a couple of more questions in the poll. So I would ask Naresh if you can pop up the question number 3 for today. Okay, so the question is, what do you currently use for the observability, log analytics, and distributed tracing? And your options are like whether you use OpenSearch or Elasticsearch, Splunk, Datadog, New Relic, App Dynamics, and Prometheus. So we have another 40 seconds for the answers. But looking at the answers, what we have out of the 34 people, it looks like most of them are using either Elasticsearch or Splunk. But I do see a couple of people using the Datadog or Prometheus and the Grafana. So maybe Prometheus and Grafana could be used for the metrics. And once we have that support in the OpenSearch, you can really use the OpenSearch to view all of your metrics, logs, and traces. So another 5 seconds. But it looks like most of the people are using the Elasticsearch or Splunk or maybe Grafana for the observability. Okay, so we have one last question. Naresh? Looks like, okay, so the question is, after this session, what you are interested in learning more? So whether you want to add observability features like distributed tracing to your log analytics, or you want to migrate your self-managed workload to AWS, or if you want to know how you can leverage OpenTelemetry with OpenSearch service. So let's see what people are looking forward after this session. Seems to be a mixed response as of now, but yeah, the majority wants to know how observability feature like distributed analytics, distributed tracing could be added into your existing log analytics. Another 10 seconds. So there is really the first option is kind of winning, as we have a couple of people who want to migrate self-managed workload to AWS. So anyway, after this, I will invite Manish as well to talk about the next step as well as the key takeaways. So I will cover the key takeaway and then Manish will talk about the next step.
Yeah, that's awesome.
Okay, so what are the key takeaways from this session? So you can use the OpenSearch service to correlate logs, traces using the observability and metric support is coming in the future. With new application analytics and the APM capability, you can use and manage and monitor your application performance as well as health of those applications. Then you can use the event analytics to live tail the logs or maybe check the surrounding logs to find the data which might be relevant to a specific error into your application. Then you can use app analytics to consolidate multiple applications in single view. Then last but not the least, there are various data collection technology which you can embed in your application. So to answer the question, which was like how you can use or how you want to add observability in your existing system. So look at the OpenTelemetry, how you can embed that into your existing application, which can do the instrumentation, collect the data, and send it to the OpenSearch. So now let me hand over this to Manish to talk about the next steps.
Thank you, Prashant. We are almost at the end, but I do have many more questions unanswered. But there are a couple of those if you could answer. But before that, so these are the QR codes. If anyone wants that for you to get quickly started, you can go for the free trial or for the workshop. Or if you know whoever is your AWS team you're in touch with, the account teams, get in touch with them, and we're happy to do specific to your environment. Whatever you're looking for, answer your questions, and anything you need from us, me, Prashant, let us know, and we'll be happy to dive deeper with you subsequently. But so there were a couple of questions which were asked by many people, Prashant, and I want to take that. In the interest of time, there'll be only two, but a quick one. So the question is, can they get access to this demo, or how they can best test the features shown here on their own? So so the observability workshop, does that show everything?
Yeah, so basically, if you look at the observability workshop QR code, or maybe as a follow-up email, we will also send you the link for the workshop. So this covers whatever demo I was showing. So it covers the trace analytics, then the event analytics, operational panels, notebook, everything. And the application or the architecture, which I was showing, which was kind of, I was referencing as the food ordering app. So that also is there in that particular workshop.
Excellent. Thank you so much, Prashant. That helps. And another one, which is again asked by many people, is do we need AWS distro OpenTelemetry collector if we already have OpenTelemetry collector? And what's the significant benefit with AWS distro OpenTelemetry? Do we have a straight answer?
So that is really a good question. So the thing is, OpenTelemetry is again an open source product, which is backed by the CNCF. So if you're already managing your own OpenTelemetry, you do not really need the AWS distro. You can continue using that one. So the only advantage of the using the AWS distro for the OpenTelemetry is you get kind of a single click deployment when you want to deploy it on the ECS or the EKS. So if you want to take some of the overhead of the management stuff, then you can use the AWS distro. Otherwise, you can keep using the OpenTelemetry, which you are already using.
Thank you, Prashant. That helps. We are at time. Thank you so much, everyone, once again, to join us. I know we could not answer all the questions. The chat room was buzzing, which was good, but we will get back to you if we have not been able to answer your question. These are, our email IDs if you want to get in touch with us to take this forward. Or as I said, if you're in touch with any of the AWS account teams, whether it's account manager or technical account manager, solution architect, anyone, get in touch with them. We have a lot more which we can share, and we can do that specific to your environment. Thanks again. Hope you found this session useful.
And
thank you so much.
And before we go, just one thing, like you will get a survey link over an email. So please do fill out the survey so that we can know like where did we go wrong, what we can improve in the future as well.
Hey, excellent. Thank you, Prashant. Thanks for sharing that.
Yep.
Okay. So thanks everyone once again.